Hello, ladies and gentlemen. Today we are going to take a look at graphing in other forms. So graphing lines continues today, but we're going to look at times when the equations are set up a little differently and perhaps other ways we can use to graph. So make sure you get this title in your notes. You're going to probably want a calculator and that notebook because we're going to sketch some graphs today. Something to write with, of course, is very important. So let's look at our learning targets just briefly. You already have these, but we are determining the x and y intercepts of a function today. We're learning what those mean. We're also going to use them to graph. And we're going to talk about graphing a line using a different type of form that you've probably never seen before called the translated form, or the pulling the point from the equation and using that to kind of sketch where that line moved. Okay, so let's remember where we've been. We've already talked about y equals mx plus b. So in this equation, remember that what would the slope be? What would the slope be of this line? Well, the slope is always what's in front of the x, so in this case, the slope would be 6. The y-intercept here is this b value here at the end. So the y-intercept is at 5. Now remember that's a point, 0, 5, because we're finding 5 on the y-axis here and plotting a dot. That is the point 0, 5. The slope from here would be what I count to find the other point that I connect to make the line. So I'd go up 6 over 1. So up 6 would be a little bit off the graph there at 11, and over 1. And then I'd go ahead and do my best here to sketch a straight line. That would be the line that we graph. Now, y equals mx plus b is a great way to graph lines, but it's not the only way, and that's important to know. So what if the equation's not in y equals mx plus b form? Do I have to rewrite it, or is there another way, maybe an easier way to graph? And the example we're going to look at today involves equations that look like these, where the x's and y's are together there on one side. You can certainly solve for the y, no big deal, and graph it using y equals mx plus b, but there are other options, and you should just be aware of those other options. So when I look at this graph, what do I mean when we talk about x and y intercepts, or just y intercepts and x intercepts in general? So look at this blue line. Again, you don't need to write this part down. Notice where the x-intercept is. The x-intercept is where the blue line crosses the x-axis. That's this point right here. This would be the point 6, 0, because it's over 6 on the x-axis, up nothing. This guy right here, the y-intercept, is actually 0, negative 4, down 4 on the y-axis. What do those 2 points have in common? Well, they have different values, right? 6 and negative 4, but they both have a 0 as part of their coordinate. For the x-axis, it's in the y spot. For the y-axis, the 0's in the x spot. So because of that, we can use that understanding to help us graph using x and y intercepts. So we have so far learned about graphing using y equals mx plus b. But there are more ways to sketch a quick graph. So please be aware and write this in your notes that using y equals mx plus b is not the only way, and sometimes it's not the most efficient way. There are others. And one of those others, option number 2 here to sketch a quick graph of a line, is to use the idea of intercepts. So when you use intercepts, the x-intercept is the point where a graph crosses the x-axis. To find it, we're going to make y equal to 0. The y-intercept is the point where the graph crosses the y-axis. To find it, we're going to make x equal to 0. So notice the opposite relationship there. To find a y-intercept, I make x equal to 0. To find an x-intercept, I make y equal to 0. Then we can plot those and connect to draw the line. So you may need to pause the video a few times here today. I'm going to go on here to sketch a quick graph using x and y intercepts. So when you graph using x and y intercepts, we want to do what those directions say and plug in zeros. Substitute zeros, but only one at a time. So for example, here in this equation, I might plug a 0 in where the x is. So it becomes 5 times 0 plus 2y equals 20. Now 5 times 0 is just 0, so there's really nothing there. And I end up with 2y equals 20. I can solve for y. I get y equals 10. Now this is telling me my y-intercept. This is saying to me that the y value is 10 for the y-intercept. So I have a point at 0, 10. Where did the 0 come from for the x, you say? Well, we plugged that in, right? We plugged in a 0 for the x right away at the beginning to try to find out where it crosses the y-axis. Now I would do the same thing to try to find the x-intercepts. So what I would do is leave the 5x alone, but plug in 0 for the y, and solve. So I'd have 5x. Remember, 2 times 0 is 0. 5x equals 20. X equals, 4. So I go ahead and have a point at 4, 0. So this point becomes 4, 0. So if I connect those two, this is the graph of that line. It'd be the exact same line that I would get if I solved this for y and did y equals mx plus b. I'd get the exact same line in the exact same spot, crossing at the exact same places. But I got there using a different method, using x and y intercepts. Let's try another one. This guy, we're going to find x and y intercepts and sketch a quick graph. So again, you just plug in zeros for one variable at a time. So 4 times 0, I'm going to plug it in for the y to start. So 4 times 0 is 0 equals 3x minus 9, adding the 9, adding the 9. So I have 9 equals 3x, divide by 3, x equals 3. So that tells me I have a point at 3, 0. 3 goes in where the x is. This is my x-intercept at 3, 0. Now I would do the same thing, plugging in a 0 where the x is this time. So for y, I'm going to leave that alone. Plug in a 0 for the x. So I end up with 4y equals 3 times 0 is 0. 0 minus 9, we could figure that out, is just negative 9. Okay, divide by 4 to get the y alone. Y equals negative 9 fourths. Well, what is negative 9 fourths? How do I even plot that? Like, what is that? Well, that would be the point 0. If I make a decimal approximation for that, guys, negative 9 fourths would be like negative 2 and how much? 1/4? Negative 2.25? Okay, 2 and 1/4. So we'll go ahead and do 2 and 1/4 as my point. So I'll go down negative 2 and a little bit more. It's an estimation. Whew, too much estimating there. There we go. And I can go ahead and sketch my line like so. And I have my line graphed using x and y intercepts. Okay, but that's not the only way to graph. What if the equation's not in y equals mx plus b form or not in an easy way to find intercepts? What's another option? Do I have to rewrite it? Do I have to keep moving things around and adding that extra step, or can I work with it the way it is? For example, this guy, y equals 2x minus 3 plus 4. Now what you could do, of course, is distribute this out and get yourself in y equals mx plus b form. And that'd be great, no big deal. But there's clues in this equation that would be handy for us to pick out now while we're talking about lines, because those same clues apply to other types of functions later on this year. So there's the two ways we've talked about so far, slope-intercept form and using intercepts, but there's a third way to sketch a graph of a line, and that's using translations of the parent graph, so of the y equals x graph. So notice there's a general formula right here that you need to write down. You need to understand that within this formula, there's a random point. We're going to pull out a point on the line, and we can still find the slope to find that second point, and we can just connect the points to draw the line. So in a translated form, you're still going to see the y and still going to see the x, but there'll be pluses and minuses of different numbers here on the end. You'll know it's in translated form because the parentheses are there, and you'll have a value here in front of the x. Notice that that's still called m, that's still the slope, but the point hk, a point on the line, gets pulled out of this equation. Notice it was a minus h in the formula, but it became a positive h when we plot the point. So that means the number in the parentheses essentially is going to change signs. But the k on the back, the number that's on the back, is going to stay the same. Positive, still positive. So we aren't going to change that at all. Now let's take a look at what this would look like. Most of the time it's the examples that help make this make sense a little bit more. So here's a third example. You already have this big box up here in your notes. Don't need to write that part down. You already have all of this. But let's take a look at what this formula or equation is telling me about my line. First of all, there's a 2 in front. What does that mean? That is the m, that is the slope of the line. Now in the parentheses, I have a -3. That means the x part of the point is actually going to be +3. Remember, that's the opposite of what you see right there. Now, the +4 on the end, that's just going to pop down and become my y part of my point. So what this does is give me a point that I can graph. So this is 3, 4. I'm going to graph him right here. And from there, I just do my slope. Up 2 over 1. Up 2 over 1. I'm going to do a couple in effort to make a straight line here. Pretty good. Pretty good. There he is. That is the line shown right here in this equation. Now I didn't need to go through and distribute it out and do a lot of extra algebra. If I can pull off the important information here out of that formula, I can sketch that quick graph. Let's do one more. So example 4, I have -2/3 quantity x plus 1 and then -2. So this is again in that translated form. How do I know? I see the parenthesis joining those two together. I see the slope still in front. So none of that has changed. Now remember that this is my slope. Now let's get that point from my equation. Notice in the parentheses, what do I see? I see x plus 1. So I'm going to place the x part to be -1, and then the y part of my point is going to stay -2. So -1, -2, over -1, down -2. This is the first point that I'm going to graph. And from there, I do my slope. My slope says go down 2 over 3. So I'm going to do that. Down 2 over to the right 3. There we go. That's where I would land. And I can just connect those two, make a straight line, and there we have it. That's the location of that line described by that equation. So far today we talked about many different things to graph. We need to know a little bit about everything because I'll tell you in the near future we're going to find x-intercepts of things that aren't lines, and the process is pretty much the same. So just be aware that all of these have value, maybe not so much for lines right now, but they're going to be strategies that we pull from later on as the year goes along. So these are kind of the foundation things we need to understand, and we might as well understand them with lines first. So we've learned that you can graph a line using y equals mx plus b because you know the slope and you know the y-intercept. We can also graph a line using intercepts by plugging in zeros. And thirdly, we can pull from the equation some shortcuts if it's in translated form. Remember, it has to look like this, just like y equals mx plus b form has to look like this. Then we can pull some information from it and use that to graph a quick sketch of a line. So you have options depending on what the equation looks like. That kind of predicts what option I might choose. So I want to thank you again for taking good notes today. We're going to practice these skills when I see you. Kincaid out.